Okay, I want to start by showing you guys something that is cool.
All right.
Okay, so this is an invention of mine. I call it Windable, and I built it in Rust. It opens my windows. And it goes down.
Did you put this on the STM32?
What's that?
Switch. It sounds like a stepper motor.
Yeah.
So
Two-stepper motors.
Rust is both the embedded device as well as on your smartphone?
No, so my smartphone is actually running Kotlin, an Android app that I wrote. But there's two-stepper motors, one for each side that run the windows, and they're both running a Rust application that I wrote, and they all synchronize with each other.
So it's a stepper tuning that you screw in.
Yeah.
There you go. That's one way to get enough torque to open it.
How many lines of code for that?
Oh, I don't know. Well, this is my Hive app, and it uses Hive. This program I wrote is called Hive. And it's all in Rust.
Mm-hmm.
And it's called Hive because, so I've been doing home automation for a long time, and a lot of that involves remote devices talking to each other over networks, over Bluetooth, over Wi-Fi, Z-Wave. Everything's got to communicate and synchronize, and with the cloud. And it's always just a hassle getting everything to talk just right, building different APIs for every single thing, and different programming languages for everything that's got to talk to each other, and it can be a big hassle. And so I came up with this on my own. I kind of built this on my own time, and it's called Hive. And it's a communication and data synchronization platform, basically. It's a framework. And it doesn't really do anything by itself, except it allows disparate services or devices to synchronize data with each other. That's what it does. It provides that functionality. And it runs primarily over just a TCP socket. So I can connect everything. It'll run and listen on a TCP socket, and then all these other remote devices can connect to that same socket, and they all share data with each other. And I've written a couple of different Hive clients. I wrote one in Kotlin that you saw. I was driving my phone. That was a Kotlin client that talks to Hive socket language. And I've written a JavaScript client that runs a WebSocket, so I can connect to Hive with a native WebSocket in an app, and I can synchronize with the same data that way over JavaScript. And I've done a Python client as well, because Python's easy. But as you can imagine, there's building all this communication software is a nightmare when it comes to asynchronous communication and loops, and so I really got kind of embedded in all the async stuff. Originally, I wrote a lot of async stuff using tokio, because tokio is kind of they've been there for the longest. I think they're the most solid framework that you can get out there. The standard async STD, I don't know, whatever you call it, async-std.
What is the way you're supposed to pronounce that?
I don't know. I've never tried.
I say standard because like standard library in C++, but I heard a lot of people online call it std.
No,
Std.
It's standard.
It's standard. Okay.
It's absolutely standard.
At least here it is.
Oh, yeah. So here's one example. So
do you afford chip? Who knows?
there's I thought,
The question will never be resolved.
yeah, I needed some sort of a runtime environment to run all this stuff in. I started with tokio because that's what I knew, but then I found a lot of references to the async standard library, and I thought, well, if Rust is building, if they're going to integrate a standard async library, I should use that instead. And so I went through the process of converting everything over to this async standard stuff, and a lot of this code is all async. Everything is async in a way, because everything's asynchronous in this Hive library.
We moved over to the standard one. Did it change how much code you had to write? Was it simpler? Just
It was almost the same. Tokio and async standard building the runtimes is almost the same. It's some slightly different syntax, but other than that, it's just whatever library you're importing into your project. And it was weird because I was making a lot of headway with async standard, just building everything that way, and I don't need Tokio anymore. But then when I was expanding my Hive program to communicate with Bluetooth, I needed to integrate a solid Bluetooth library. I didn't want to write all that by hand. So I can show you what I'm using here.
Having rolled a big chunk of low-level Bluetooth stuff by hand, you don't want to do that.
Yeah, you don't want to do that. But I ended up using this library called Bluster, because I was running this on Raspberry Pis to test my Bluetooth, and I can connect to it with my phone. I've done it over with my Android phone as well. Bluster turns out to be a pretty decent library to work with, and so I've integrated that. But the problem I ran into is all of my runtimes are running in async standard, but Bluster has a plugin when you connect to them that requires a tokio runtime. And so I couldn't run the Bluster in my async-std runtime. So, depending on what third-party libraries you're connecting to might kind of dictate what sort of runtime environment you get to use. So here, I'm using my Bluster for when I spawn a Bluetooth central server.
So you just have another thread that's got the Tokio runtime running in it?
I do. So this spawns a thread. This is actually running it. I think this is async-std. Task. But for the Bluetooth stuff, I did have to spawn a Tokio thread. Oh, that's another 18 one right there. That listens for events.
So is there some sort of shim that will wrap one to be the other?
Are you running standard inside of Tokio, or the other way around, or are you running parallel?
They run separate in their own threads. I don't usually run them together. Yeah, so here's one. Well, that's just a sleep. What do I actually spawn a thread? Peripheral is Bluetooth stuff. That's probably why I'm using sleep there. Oh, there's a Tokio runtime. And I'm actually looking, I'm running that inside of a standard STD thread. Huh. I don't remember why I did that. I wrote all this code about 1.5 years ago. And it is funny. Well, it wasn't funny, but it's interesting. I had a really bad accident at the time I was writing this, when I first started writing this, that caused some rather severe brain damage. And I kind of forgot everything. So most of this library I actually wrote while I was recovering from, brain injury, and I couldn't hardly remember anything. So a lot of it is, if you read through it, it looks like it's written by a crackhead, and I'll admit to that.
I did not know that crackheads wrote. That's cool.
Common, very common.
Oh yeah. I spent most of the time writing this was just trying to remember, how to write code, because I knew that I was a programmer, right? It's like I remember I'm a software programmer, and I remember a few people from my life, but most of my history is just gone. And I was like, well, I don't know. I guess I got to learn how to write code again. And so then I picked up this Hive program. Well, it's funny because I woke up in the hospital, right? And it like a month had gone by when I woke up in the hospital. But it was interesting because during that month, I was actually awake talking to people. But I have no memory of any of that. And so it's like I woke up one day and it's like I don't know what's going on. But I remember having dreams, and I had strong dreams of Hive while I was unconscious. And so the first thing I asked my wife, because she was in the hospital with me, I said, "What is Hive? That's an important thing to me, and I don't know what it is." And then I realized, oh yeah, that's a program I started writing. And when I finally got home, I was able to pull up, my old GitHub stuff, and it's like, oh, there it is, and then it started coming back to me. But it was really weird because I had powerful dreams of this Hive program while I was unconscious. It was weird.
I had a concussion once, and for about 5 minutes, I couldn't remember where I was or who other people were. No, I think I knew who other people were, but I couldn't figure out why. So first of all, the way I got the concussion was I was wakeboarding.
Oh no!
And so I smacked my head into the water. So when I came to, I was behind a boat. I didn't know where or why. And I'd been wakeboarding for like 10 minutes.
And you were like floating in your thing.
Just
You were floating like in a life jacket.
No. I was actually wakeboarding.
Oh, you were actually wakeboarding. Oh my gosh!
So what happened was I had the concussion. I got back up, and then I was going, and I was just on autopilot. and then about 10 minutes later, I came to, and my dad's like, "Yeah, you've just been standing there balancing the whole time, not doing anything." And I couldn't remember stuff, but over the course of like 20 minutes,
Wow, that's amazing.
stuff
Well,
started
yeah.
coming back.
My,
Anyway, Pizzi's here.
my 9-year-old daughter had a bad concussion this year, and she forgot how to read and write.
Oh wow.
In 4 months' time, she's back to where she was.
Yeah.
But yeah, she can do math. She usually doesn't like math. She's losing her math skills, but reading and writing, which is what she loves, she lost all that and had to be retaught.
Wow.
It came back quickly and within 4 months, but
Yeah.
it was really weird. Never heard that before. Just got knocked so hard went out her left ear or something.
Huh. Okay, so the Spawn Bluetooth listener, this is a method that it listens for Bluetooth peripheral devices that want to connect with you. And so it spawns a new thread, just an async standard thread. But within that thread, I had to launch a Tokio runtime to run my peripheral server in.
These pizzas are smaller than I thought.
So you were working on this before the async syntax stabilized?
I think it was about the time that async await was just kind of, it was becoming popular. Because I don't remember ever using async await before. But when I started writing this, I was like, I need to write some asynchronous code. Because I had to handle a scenario where like multiple clients are connected to you and you update a property, but then you've got to notify all these clients. I didn't want one client to wait while I'm notifying another client. It was like, so I need asynchronous events so I can spawn responses to all the clients at once. And then if I need a response, I can get the response. But otherwise, they're not waiting on each other.
Plates,
Yes, those are plates. You might need
napkins, paper towels.
I'll see if I can get something.
So my understanding is that Tokio came first and was a way of doing asynchronous stuff in Rust before these standard decks came out. And then they had to sort of rewrite the library to use async, the async syntax.
Yeah.
I think so, yeah.
Yeah, it was previously based just on futures and closures and that sort of stuff.
Right.
So besides the issue that these runtimes are incompatible, you have to choose which one you're in. Aside from that, is there any advantage of async standard over Tokio at this point?
I don't know that there is an actual advantage. I've in my experience, they do basically the same thing.
Yeah, I think the main advantage of async standard is that it's based on the standard library APIs. So you could conceivably take a synchronous program and just change which libraries you're importing. So rather than importing things from the standard library, you import them from async standard. And then you just, you don't have to rewrite much.
Now, in your embedded context you were doing here, you were running all this on a Raspberry Pi?
Yeah.
Okay, so you did have an operating system. You didn't have to worry about running with no standard or anything.
Yeah, I was running within an operating system. It wasn't entirely embedded.
For the people who are
There's plenty of embedded systems that have operating systems.
for the people who are online, can you hear us, or we haven't heard any comments or questions coming from the people online?
Loud and clear.
Got a thumbs up. Okay, everyone else is just lurking.
Yeah, so in my peripheral server, it's running another async task here that reads bytes. So it's basically running its own task where it's constantly reading bits coming on the stream. And then I kind of built my own protocol for packaging data into binary bits. It's really efficient and lightweight. I can show you. I can't remember where it is.
So, do you have
Properties.
something to do ZWave in this or no?
I don't yet. That was actually the next thing I was going to do, because I had a Z-Wave, a USB Z-Wave stick that I've used before on Raspberry Pis actually. And then my next part of this project was to communicate over Z-Wave. Right now it just does TCP network. It also does Bluetooth and WebSockets. Shoot. Oh, that's not what I'm looking for.
Apparently some of us here are a little quiet.
Well, that's spicy.
Oh yeah. Here's where I package properties into bytes. And it's neat. So I package the name is just a string of UTF-8 bits. I package the property name. And then the next bit is a property type variable. And based on that property type bit, I either package a bool. If it's a boolean, it's just another single bit that gets put on the stream. Or if it's a string, then I package another bit with a string size, and then there's the string after it, so I know how many bytes to read for the string value. And then for integer values, depending on if it's what type of integer it is, it'll package one 8 bits, 16 bits, 32 bits, or 64 bits. And so it looks and says, oh, what kind of value is this? And so it uses kind of the least amount of bytes it needs to send on the stream.
So why did you choose to do this custom serialization as opposed to, say, using Serialization or something?
Because it was fun.
Okay. For your own project, that's perfectly valid.
For my own project, yeah.
Well, what is the one that Google has? What's that called? They've got a binary.
For protocols and gRPC.
Protobuf.
Yeah.
Protobuf is similar to this, right?
I'm not familiar with Protobuf. Probably, though. It sounds like it.
There's BJSON, and then I think Protobuf is a step above that. But I think this may actually be similar.
Yeah, and then here's the deserialization. Bytes to property. So this deserializes the byte stream back to a property name and a value, essentially. And another step that I was thinking of doing here to make it the actual stream smaller was on initializing when it first initializes with another peer. They exchange data, and so the peer says, hey, I'm here, and then this other client, I call them peers instead of client servers. Technically, they're client servers, but everything in Hive is I consider a peer because they all just work together.
Using some syntax I don't recognize. If you do the range string length, does it assume beginning at 0?
I think so. Yeah.
Okay.
Dot.
Does it
Oh
shorten
wait.
doing
Slice dot. Yeah, it just goes from 0 to the name length.
that? Okay, so I didn't know that shortcut.
Yeah, you can also just do dot dot. And it's the whole thing.
I'm used to doing 0 colon 20. Okay. Is that been there for okay.
Yeah, I had forgotten about that syntax, and then I ran across it in my code. I'm like, what? Oh, yeah, that's what that is.
I changed the languages enough times I constantly have to Google things to remind me how the syntax is in that language. It's like, I know what this whole range is in this section.
Oh, but one thing I considered doing that I never got around to was when two peers actually exchange information, the one peer sends all the different properties that it's managing. It says, here's all my properties. And then they synchronize with each other. One thing you could do is if you have one one peer that's kind of in charge, it could actually assign a binary value to a property. And so when it exchanges the property, it says, here's a property, here's a binary tag that identifies this property. And then every property would only need to be identified with a single bit. Instead of sending a whole property name, I can send a bit that identifies a property value. But that would only work, if they've already exchanged data and they know what's going on.
So I was thinking initially that the pizza would get here because I ordered it plenty early, but apparently the place across the street doesn't know how to find us within 20 minutes. And took a look. Anyway, took a little longer. But we didn't officially open or do an intro, and I don't know if we just want to continue chatting about this in the way that we have been, or if you had more of a presentation style approach that you wanted to go through. There's this and there's this and that. Either way, it's fine. What do you think?
I didn't really have a solid presentation, other than if I can, I try to show you how Hive works, like live.
Okay. Well, let me just say officially, welcome everybody. now that we've had some pizza, in the future I'll try to get the pizza a little earlier so we can chat, talk shop, and eat a little bit, and then get started probably around 7, or depending on if we move to Lehigh, then we might do pizza at 7. Presentation started at 7:30. But anyway,
So we're here today, but at Weave next month, or what was decided on that?
so I don't have a firm decision on that yet, but yes, next month we should be at Weave because our presenter is part of Ford. Do their stuff at Weave. So we're considering the possibility of.
I can only remember her handle. I can't remember her name right now.
I don't remember her name either.
She runs the Goat Meetup. At least she.
Mariah.
Yeah, Mariah.
Yeah, that's right.
Okay. Yeah. Anyway. So, welcome everybody. We're just gonna go see how this code works, and feel free to ask questions. Those of you that are online, butt in at any time. We will here locally.
So how are you using Hive to open your window? Are you just sharing a property as what the height position of the window should be, and the motors sync that position, or?
Oh, so I use these 3 properties to sync my Hive motors together. So there's a turn property that's either 0, 1, or a 1, 2, or 3, or maybe it's 0, 2, 3. I don't remember. And then there's a speed property that tells the motors how fast it is turn. And the PT is for a potentiometer. I was using the boards that I use to talk to the step motors have a digital potentiometer you can control that limits the amperage that it puts out to the stepper motors, which can decrease or increase the torque on the motor. And when I was experimenting, I've got like 3 different levels of the potentiometer. There's like 0.5 amps and 1 amp, 1.5 amps, and 2 amps. You can set a potentiometer on it. And so I said, and since it's digital, you can set it whatever you want just by turning on a pin, and you can set the potentiometer to whatever you want. It's kind of cool.
So turn means just start turning continuously at that speed.
Right. And like turn 2 means turn clockwise, turn 3 means turn counterclockwise. And clockwise and counterclockwise aren't entirely intuitive. So it's just turn one way or the other.
So if you're turning, how do you? I mean, the property being shared is you should be turning now.
Right. It means turn now.
But there's a race condition. Those 2 motors are not going to. What's the potential lag between the 2 of getting the command? How much of a head start can one get over the other?
Well, I mean, if the network was really bad and there's interference, you could have any amount of lag. I didn't have like any lag when I was doing it, and when they were just talking over network or even Bluetooth, it was almost instantaneous. But I rebuilt this system. I was originally building it so the two motors synchronized with each other, over the network. But then I built a system where I could run a cable between the two that actually connected the turn pins on the physical devices. And then I'd only have to tell one device to turn, and they both get the same signal. They both start turning at the same time.
Okay. Yeah, that's a better way to.
Yeah, that kind of solved
The
the
two motors.
Yeah, hardware beats
Not,
software reliability.
right. But I never had a
Working
problem
themselves.
with lag before, but I did. That was a concern of mine that I didn't want to have to deal with. So that's why I kind of built that crossover cable solution.
Before you used Rust, what had you done asynchronous programming in previously?
Before Rust, probably just with Qt, using the Qt events, signals and slots. In fact, this was originally designed with signals and slots, based on the same concept. But I had a problem with the signal slot solution. Actually, I think I made a note of it in here. What is a signal? No, it's not there either. Well, one issue that I was having with signals and slots is I couldn't clone them. And I kind of needed to be able to clone most of my logical objects. When you're sending stuff around on threads, you deal a lot with asynchronous reference counters and whatnot. And the problem I was having with my original signal slot solution was I couldn't clone my signals. So I changed them out to use a stream. Oh, no, that's not the same thing. That's something else. Where did I put that? That wasn't in my mind.
So, compared to your experience using C++ for async stuff, signals and slots, and moving to Rust async, is there one that you prefer at this point? Or how big was your learning curve going to async?
Going to async was a massive learning curve. I basically just had to learn everything from square one.
Really?
Yeah. Because it was all different. It was a mind stretch. That, and I was recovering from brain damage. Oh yeah, see here, unchanged was fun, kind of Qt-like signal slot binding, but it's not necessary. Without the on-chain signal, I can implement clone if I feel so inclined. Right, so now I use a stream that I can listen to. So I have a property. Every Hive peer, they share properties. When first connect, you say, here's all my properties. Every property has a value. The value is basically anything. And then each peer will connect to this property stream, which is essentially a stream of events, just asynchronous events that can get sent to it anytime. So like, and I was originally sending everything in TOML syntax before I built my smaller data parser. I was just sending TOML strings, and so I would parse all that out. And I still do with my configurations. So I can configure a peer and all those properties in the text file. So I don't have to like recompile everything if I want to change the config. I just rewrite my text file. And so it parses out all my properties from that text file to tell it how to operate. But each property has this set value, and if it changes, or if the value doesn't equal the original value, then it runs this on next holder, which I think this is an art function. Oh, so I can actually call this on next holder from another stream. If I want to say, hey, when this property changes, then the next value, then trigger this event, and then I can just call this onNext handler. But this stream, this property stream, is what gets notified if it has next value. So you can kind of see in some examples, I've got some crazy examples. And they all use async standard to spawn listening. So here's as simple streams. So here's all my properties in TOML format, and then I start an asynchronous task that binds to the property thermostat name. So right here, I get my server Hive is running from this bunch here, and then I launch a task, and it listens to next. So this is running in its own task or its own thread, so it doesn't block anything else. But then anytime this property changes, this gets notified, and it updates values here. I learned to use these. The CVAR is these are interesting. Convar. They're condition variables, right? And these condition variables you can stack in an arc or an asynchronous reference counter, and then you can clone them as much as you want and pass them on to other threads, but they all synchronize anytime.
So I don't know what a condition variable is.
So like
It's basically it's sort of like a semaphore type thing,
Okay.
except it's just one variable, and anybody can like block on its change,
Right.
and then
so the interesting thing here, see I cloned I've got this atomic U size counter that's cloned like crazy. Condition variable. The condition variable is kind of like a mutex. It's a special mutex that just has a self-assigned property that other things can block on. So here I clone it. And then I get my mutex and my condition variable out of there. And right here, when I get an update that this property changed, I notify the condition variable. And then in my scripts down here that's actually running this example, this is it here. When I update a property, I wait on this condition variable. The advantage to this was before I would just wait for a second, right? Just wait a second for this asynchronous task to happen and then check to make sure it happened to verify. But that just goes slow. And so when I switched to using this condition variable where I would actually block and then it would get notified right away and then continue on, this whole thing would run in milliseconds. Let's see if I can run it. And before it would take, half a minute, 20, 30 seconds when I was just doing timed waiting. So these condition variables or mutex properties are a great solution when you're doing asynchronous testing.
Okay.
Good. That was fast.
So are you programming in mostly C++ today, or Kotlin, or?
Today, I'm actually writing code mostly in Kotlin. So I'm actually a little bit rusty with Rust.
So you wrote this. What was in competition? I mean, you're using CLion, so I assume you've done a lot of C++. You've done Qt, obviously. So
Right.
So looking now at Rust, if you had to go back to using a systems language, would you go back to C++, or would you never go back and do Rust from this point on?
Oh, I love Rust. I given the opportunity, I'd go back to Rust any day. I love doing it. It's the kind of thing where it's like, I would never want to interview and do like a Rust, program with somebody to show them what you can do. Because when I'm writing Rust code, I don't know about you guys, but it'll take me most of my time just trying to get the code to compile.
Benefit of a whiteboard exercise opposed to.
Yeah, But
if
then
it
once I
compiles,
finally
it
get it to
runs.
compile, it runs. Yeah, it's the kind of things like once you get it to compile, it just works. It's great like that.
Yeah. Well, the more times that you do certain patterns of code, the more confident you get at getting it right the first time. But, you know, every once in a while, it's like, nope, that doesn't live long enough.
Yeah, I tried to convince some people to try to do Rust coming from some other languages, even though I'm their boss. It's been a bit of a tough sell because they're very comfortable in the tools they've been using for 10 years. Want to stay in that. But I would only want to go back to C++ because something really strong compelled me to do that with all the issues I remember of memory leaks and threading problems and all that stuff. I know that they've made improvements to the smart pointer since I used was version 11 or something, but are you doing exclusively Rust now, Levi?
Much. Every once in a while, I have to touch some Go code or some code.
Oh, Go's fun. I wrote some Go. I like Go.
It's not bad.
So, what were the most pernicious bugs you had to deal with?
So the memory is a little bit foggy on it. But what is the most pernicious bug? I did get stuck for a while in some of my property handling because I was getting confused with Bluetooth stuff. Bluetooth was hardest. Trying to integrate Bluetooth, and it was because I had to learn how all these Bluetooth libraries worked, and they were just all nuts. There's just not a good solid Bluetooth library out there to use.
Bluetooth itself is nuts, so
You know,
anything you build on top of it,
it'd be nuts. Right.
Is Bluetooth like USB, where the numbers increment and the standards have nothing to do with each other?
Well, they tack on some new things, like Bluetooth LE is like completely different.
Oh yeah.
And there's just lots of things that are like things you already know, but have a different name and work slightly differently. There's like a TCP-like protocol, but it's not TCP. And yeah, just stuff like that.
Are these Bluetooth libraries pure Rust, or are they just wrapping C code?
These libraries I'm using, a lot of them are actually wrapping some other C libraries.
So you typically, so the thing about Bluetooth is that there's like a defined protocol to communicate with the Bluetooth controller, which does most of the actual radio communication. So you're speaking like a network protocol to another computer that has the actual radio interface on it. So it's
Yeah, and to make things more complicated, as you can see, I've got a MacBook Pro. I do all my programming on my Mac, but I'm writing in a Bluetooth library that will only compile and run on a certain version of Linux. So
so does it use the a C library to communicate with the Bluetooth stack?
I think it does use a C library to communicate with. I can't remember what the stack it uses.
BlueZ is the standard Linux Bluetooth stack. And they kind of deprecated their C library interface in favor of a dbus API.
I think it does do some BlueZ stuff. This Bluster library
Is that Bluster library available on the Crates.io, or is it directly from GitHub?
I think it is available on the Crates.io. Because I was pulling it directly from GitHub for a while because they had updated it. They had a newer version of it that I needed. I needed a change that they had in the latest version that didn't exist in the Crates.io. So I had to pull it from the master branch on GitHub. But they've updated their version, so it does actually work now. Yeah, this is the Bluster stuff. Yeah, the numbers from there, I guess. That's too bad.
So with my Toml file, I can now connect to any Git repository of any type, or is it?
Yeah.
Okay.
You can reference either Git repositories or paths on your file system. And you can see that.
I've been with my private repositories. I've just been using relative paths.
And you can also run your own crates repository. So, private crates IO style repository that Cargo can pull from.
The only Rust developer where I am is my comment right here.
Oh yeah, see right here, blurs. I was using this blurs library as well. It's dependent on dbus, which requires libdbus1.dev.
dbus is sort of an inter-process communication bus for mostly Linux.
Yeah, it's Linux.
It can also run on some other Unix-like operating systems, but I used it in Unix, which really isn't used unless they're using legal or working.
Well, I remember that.
Yeah.
It got bought out by BlackBerry. Is it still around?
Yeah, well, it was owned by Harman before it was bought by BlackBerry. Bought it from Harman,
Yeah.
and Harman bought it just to make sure it stayed alive because all of their automotive head units ran Unix.
I actually tried to see if I could cross-compile Rust Hive to run on Android, and I had some success with that, but I couldn't quite get it to run how I wanted. So then I ended up just rewriting a Hive client in Kotlin.
Yeah, I think Android might use different Bluetooth stack now. There was a big fuss around when BLE came out. Like Samsung was like one of the first ones to switch to stack. And so,
Huh.
yeah, it was a big thing.
So
Okay, I don't understand why my Bluetooth devices sometimes don't pair. It's just a very
That's
complex
just
protocol.
just Bluetooth. Yeah, it's complex and it's managed by a gigantic industry alliance with a bunch of different companies that are all separately creating their own implementations of it. They all get together Bluetooth special industry.
I started building a Rust plugin as well, so, or REST plugin, so that you can synchronize a property with a REST endpoint.
Nice.
I never really finished that. I made some good progress, so I just want to see if I run. This just listen example is just what it says. It just listens. It just starts up a Hive service on my local Mac here with these properties. But if I enable Bluetooth, it should also start up a Bluetooth. I think they call it a Bluetooth Central. Is kind of acts as a server, and then the peripherals connect to the central device. I want to see if I can actually connect to this. So you can run. But yeah, so implementing Bluetooth was the hardest part. Oh, it broke. Did not find time in Tokio. I don't know why I'm using a Tokio timer right now. Oh no, my battery's low. I've got a charger. Oh, getting this stuff to I ended up building a cross compiler that I could deploy. I could build my Hive program and deploy it straight to a Raspberry Pi. And that was a little bit tricky too. I ended up just building a Docker container that had all the or all the Raspberry Pi libraries that I needed.
Mm-hmm.
And then I would actually run the Rust cross compiler on the Docker container and it would build my library. Just because it's so much faster than trying to build this whole thing on a Raspberry Pi. Yeah, that was a nightmare.
I know people that try to build on Raspberry Pi when they're doing that. That's not how anybody that is really doing these things does it.
Yeah, I did that for a while, but then I was like, all right, this needs to end. And then I spent the time figured out how to build a cross compiler for my Raspberry Pi.
Reminds me of how the original Mac Lisa was ended up being the development tool for the first 128K Macs.
I actually have a Mac Plus at home. You can run the they call it like the tool bench or something. Have the compiler. It's actually sort of a Unix-like environment. It's sort of a shell within just a full screen window. That
I actually wrote a script for doing my cross compiler that launches Docker. It mounts all the volumes that I need so that it caches the builds that it needs. It caches the .cargo directory. And these were some Bluetooth libraries I needed for dbus.
Enoch, couldn't you just...
Bluetooth listen, I'm not sure why that's there.
Couldn't you just use standard cross-compile, or was it...
that are all centered around building cross-compile environments, so you can do cross-development for embedded systems.
Right, yeah. Yeah, there was a library I think I started playing with that was a Rust cross or something. And it was okay. It does basically the same thing as just doing a Docker image or something.
It's fairly easy if your project's like all Rust.
Right.
But when you need to link to native, especially if you're going to statically link to native,
Like dbus.
Yeah. Then you've got to have that library for the system you're linking against
Right.
in your
builder.
Build root.
Yeah, so I learned all about that, and that was hard.
You wrote your own macros?
Yeah.
Show us your macros.
Yeah, I'd be really interested in knowing how you
Using the macros by example or the product macros.
I don't even remember. Hold on.
Macros by example, it's the name of the one style of macros that have been around in the language the longest. Ones that are is it def macro or whatever you use.
It's the macro you use if you're a demigod. And once you become god status, you do procedural ones.
Yeah, the proc macros are all like written out in Rust code, and you get the different tree data types from the sim library or something. Whereas the macros, by example, are just define the macro with like a pattern that it's going to match into different kinds of tokens, and then for each way that it matches, it's like a big match statement. Where
I'm pretty sure that's the only macros I know of.
yeah, it's the one that's in the language now. The procedural macros are like compiler plugins.
Can you click on your Hive macros file, please?
Have you heard much about Zig?
Hive macros.
Yeah.
I like his approach. No macro run, just like
So
Zig.
you look under WebSocket, handlebar,
Put
Hive,
some sort of
look here,
annotation on it.
WebSocket, handler, Hive, Hive macros.
Run before the compilers. The results should be
Yeah, so he had a macro.
stored.
So it looks like you had one, but
Yeah, I started, but apparently didn't get very far.
Yeah, macro rules. That's the macro that you use to invoke or create macros by example.
Yeah.
Were you using this to try to make a the print statement a variable number of arguments function?
That's it, I remember. I know it kind of sounds like I didn't actually write this code, but I did. I promise. But I lost a lot of memory, unfortunately, and it's a struggle.
Yeah, I have written a few of those macros before. It takes a little bit of practice with it before you sometimes makes a lot of sense. Once you figure out what the different things mean, it's not that bad. It's like a match statement on steroids.
Yeah, I've done a lot of match statements. Those are always fun.
So I don't know if there's more code you want to go through here. I'd be curious, the people who are on the phone, online, whatever, just to go around here what people have been doing Rust lately in their own lives.
Yeah.
So for instance, I'll go first. I recently had to do some data science on some video and image data. And so I pulled up my Rust code to do that because it's a large amount of data, or I had some tools there. I had two steps. I was writing Python code because I would take the big number crunching and export those results to some text thing, and then take it from there in Python stuff. So therefore, data reduction of 100 to 1 with the Rust, and Python was fast and arranged stuff at that point. So that was fun. But still, I'm still mostly in my algorithms, number crunching, safe space, anything like networking, async. I haven't done any of that stuff yet.
Well, what was neat is when I first was running Hive on a Raspberry Pi, I was curious to see what kind of resources that it actually takes up, just to see how well it runs, and it was like almost none. Like memory size was quite small for when I did a release build. It was like I think only 2 or 3 megs or less. It was tiny.
Used to running Java.
Yeah, right.
Yeah.
But then I would watch the CPU process to see what happens, like when I'm sending data and it's actually synchronizing between multiple clients. And the CPU usage never spiked more than like 2 or 3%. It was like, wow, this is so efficient, and this is great. I'm running a network server, basically talking to half a dozen different clients, synchronizing data, and it's used like 2% of the CPU on my Raspberry Pi.
That,
Thank
I'm
you.
gonna have to go in just a bit, but you guys are welcome to keep hanging out and talking. Eric may or may not show up. He went to the wrong place.
Oh, no.
So he said he was still coming. Like, in response to something that they were kind of wrapping up.
It's like, he should know this place. Anyway.
Well, at one of my last jobs, we did talk ZWave with Rust. And what we'd done is we had basically cross-compiled. We had a Rust adapter that talked to the ZWave stack. Oh, what's it called? Zip Gateway. Talked to the Zip Gateway stack, I think, just in Rust. So we had a Rust library that did talk directly to the other C++ libraries on the Zip Gateway. But then we could just communicate easily with ZWave stuff that way, just with pure Rust. So yeah, we use Zip Gateway.
So Levi, I know you're doing lots of embedded stuff. I forget precisely in what context, what devices are you working with? What's the market?
So I don't do work with embedded stuff. So
What about those audio devices? I mean,
So what do you do?
I work for a security company, Red Canary.
Okay.
And I do a Rust-based system monitor program Cool. It integrates with our backend service that monitors activity across your all your computers, basically, to detect malware and intrusions and that sort of thing. So most of what I do is try to figure out how to make sense of incomplete data from Linux.
What's the other company again?
Red Canary.
Red Canary. Going to display SolarWinds one day.
This was interesting. This peripheral object I wrote for Bluetooth, it just has a single run method that is like really long.
300 lines long.
It's 300 lines long for this run method. And it just does a lot of, well, it starts a task, starts reading bytes, gets characteristics.
Is it looping or is this just flow?
That's it looks like it's just launching a bunch of separate threads, and all
It is
the
launching-
code for the threads is in line. So it
Yeah, it launches a
It
task
keeps-
here. Insert some data. Building stuff still. This has an event.
Did you write any test code?
Yeah. I wrote this streams as a test code. This basically runs most of the other processes that I've done. Like when I'd implement a new feature, I would go and add that feature to this streams. This middleman test was interesting because the streams, I think, is just two different peers communicating. The middleman has a third peer that monitors data. So like one peer will say, hey, I have these properties, and this peer over here will say, okay, well, this property is now this value. But then I would verify that middleman has also received the same property updates. And so that's why I built this, that I can run and test that.
That's pretty cool.
So it's got my server hive.go. Where's go? Oh, that's my hive program called Go. Interesting. I totally wrote with you guys at once.
Does anyone use the Rust test library stuff? So you can say cargo test.
a bunch of my code has embedded unit tests in those that run with cargo test.
Yeah, the cargo testing just runs all these tests.
It took me a long time to realize that some tests should go in the file and some tests should go in the lib thing. And the difference between your unit test and your integration test, that was a different paradigm.
Yeah.
But I like test-driven development, and with algorithm stuff, it works very well.
Yeah,
And it's pretty slick.
I try and keep the algorithmic things separate from the glue code. Unfortunately, a lot of the program that I'm working on is glue. There's like some core data structure stuff, but the idea is just to get data out of the kernel and send it off. But there's a bunch of
Oh, yeah, so
cleanup that needs to be done before sending it off.
How many other people are doing Rust with you?
About 3 or 4 now.
Oh, cool.
yeah, so the way this middleman works is I start up a server that's listening on port 3000. And then I've got another client called middleman that connects to port 3000, but it's also listening on 3001. And then I've got this client hive down here that connects to 3001. And so like the one's connected to this one's connected to that one, but they still share data back and forth. And then
And that you're using Unwrap in other places.
You what?
You're using Unwrap in other places. You'd never have to worry about a real error. Or is that just some error?
Unwrap? Oh,
Are you getting back? Are you doing that on a result or an option? Because if it's bad, then you'd panic. Have you ever had this program panic on you?
Well, I'm sure I have, but I've probably had this returns an option. So an option, if it returns none, the unwrap just doesn't run. Is that how
Unwrap
unwrap.
panics.
it panics? Okay.
If you really, when I write prototype code, I use unwrap because it gets me there faster to get the program running.
Right.
And when I go to production, I handle the errors unless I'm absolutely certain it's absolutely impossible to ever have the bad case.
Yeah.
But this is a test program, so it's handy to have your test program handy.
I noticed this main code was using unwrap a lot. He's using it as well. I mean, part of the issue with Rust compared to, say, C# or Java, you have all these exceptions that could be thrown, but you can also be blissfully, at least in C#, you're not required to handle the exceptions. You can be blissfully unaware of them if you chose to.
Yeah.
And just let it get thrown all the way to the top of your program. In Rust, you have to deal with stuff, but if you choose to just unwrap it all, you sort of ignore it and just wondering, okay, just how much does that come back to bite people? Because most of the stuff I do, I rarely have the error case situation, but I've had weird stuff happen too.
Yeah, the field is full of weird stuff.
Yeah.
I lost a bunch of time today to a customer that tried to install our service. It turns out that it broke some of their production stuff, which it absolutely shouldn't be able to, because it's not using anything that could conflict directly. But I haven't confirmed exactly what's going on, but I found a bug report. They're using an old Ubuntu version.
I think you were in Florida. Did you ever move to Florida?
Maybe a couple months.
Okay, it's still not yet. Okay.
Yeah, so birthday money was first for me. This is nice.
So in 2 months, I can start, when I see an article that starts with Florida Man as a headline, I can start looking to see if it's you.
He's not Florida.
In 2 months.
So, in all honesty, you guys are probably the first people that's ever looked at this code that actually understands any of it. I've never had a peer or code review or anything on any of this stuff. And like I say, most of it I wrote with brain damage. So.
Well, that's what got us all into writing Rust in the first place. There had to be something wrong with this to try.
Yeah, right.
Yeah, I mean,
They're all a little brain damage to begin with.
You started all of it.
and there's definitely a different standard of work for your fun hobby code compared to something that you're going to be supporting and running on other people's machines.
Right. Yeah.
Yeah, with my team at work, I've eventually got some turnover on my team to now the average experience on my team is more than 15 years working with hardware. Because in our case, we were running a $500,000 scientific instrument with C# code when I arrived. And I wrote, out of the 100,000 lines of C# code, 5,000 of those lines are Rust code. And that's where half all the CPU time is spent in my code, because it's the one that's actually handling the string of data coming from the machine, and everything else is just around user interface and stuff like that. And the people originally were working on this thing is that if you're using C# developers, where are you going to find them? And the answer is, well, they're usually web developers.
Yeah.
And for them to understand the type of errors you have to worry about when dealing with hardware was a bit of a learning curve.
Yep.
Because hardware, I mean, people think computers don't know what they do. It's an analog world out there. It's a weird thing.
Yeah, the thing that I ran into was most likely a kernel bug. And it's usually not a kernel bug, but sometimes it is. It's usually not a compiler bug, but sometimes it is.
Oh, you know what another interesting bug was too? I've got some other software, my Windable software that implements this Hive for synchronizing data. It's also written in Rust. But it's this Hive software almost exclusively uses tasks for everything. The only time I'm spawning a new thread is mainly for Bluetooth, because I have to spawn a thread for the tokio listener.
Multi-threaded runtime.
Right. So there's a couple of threads that I do spawn. One's for Bluetooth, and then maybe a few others. But everything else I use tasks because tasks are lighter and faster than threads. But with my Windable software, I'm spinning off other tasks that launch, the Hive processes within them to communicate with each other. And every once in a while, I would have this weird bug where a task would just get locked up. The whole system would stop. It's like it's stuck on some task that is awaiting something to complete.
Yeah.
And everything would just hang up. I was like, what's going on? My solution to that, though, was to move my Hive process out of a task and spin it off in its own thread. And that seemed to help. Everything just kept moving along after that.
Yeah.
All right.
But yeah, if you're not careful, if everything's in tasks, you can get to a point where like two tasks are waiting on each other to do some sort of completion, and you end up in a stalemate.
Yeah.
Sounds great.
Deadlocks sort of thing. Rust can't protect you from those.
No.
I did not get the sense that we had consensus and confirmation through Discord, so I was not expecting anything. I got the sense that we were exploring options.
Right.
So,
With our machine, we had different hardware subsystems which you had their own socket connections, and the web developers I hired, they wanted to do everything with asynchronous code.
Oh yeah.
Because they're used to handling multiple client connections. It's like, well, no, you have 8. And part of the debate we had is if you have 8 threads, one for each
Yeah, I'm
subsystem,
sharing my screen.
you never
I think-
the issue of bugging
Or
your
I
code
was.
and the blocking it, what's going on. Or at least it doesn't go beyond the one hardware system where that is, because that sometimes would happen. You would the whole thing with async all the way down, running this inadvertently blocking on something.
Some fun
Led to some
hardware.
weird bugs.
I don't know where my screen is. I'm sharing anymore. Am I still sharing the screen?
So Eric, you're writing drivers in Rust, right? For games?
Among other things, not for games, for gaming devices. Specifically, I've been most recently I wrote some code against needing kernel level functionality, so I can do just raw memory mapped I/O against peripherals on the motherboard.
So by gaming devices, do you mean like
Cooling
a
and lighting
machine,
stuff.
or like
Cooling and lighting on desktop machines.
so it's like slot machines, gaming devices,
Or
or
PCs, people's home gaming rigs.
okay,
Yeah.
that kind of game device.
Yeah, we're pretty vertically integrated. Sell all the parts you need to build your machine, and then all the stuff you need to talk to those fancy devices that we put on there for your lighting and cooling. Like you can control your fans the way you want, like you set RGB elements however you want, because gamers love their RGB. Gotta express yourself.
Yeah, you got to be at least this much of a geek to buy one of your products.
Well, sorry, my time thing's not working anymore. That used to work, I swear.
Which thing?
Oh, this tokio.time apparently can't find that anymore.
Take care, Peter.
See ya.
Yeah, the APIs in Tokyo change every once in a while.
Yeah, there must have been an update that's no longer there. Or it's different.
You can find the docs for it somehow.
Good.
So, what's the governance on async standard versus Tokio? Because is it the same way everything else with the Rust language? It goes through
Yeah,
that large governance process to make any changes?
No, Tokio and async standard are completely separate from the core language. They're not managed by the. I think there may be there is an async working group where people can collaborate on things related to async in the language and libraries and things like that. So they have regular meetings. Like there's also an embedded working group where people working on sets of libraries for embedded systems. And these are mostly like smaller microcontroller style embedded rather than like an embedded Linux.
Have you ever attended one of those meetings or watched the videos of the meetings?
I haven't done the videos. I think they mostly do text chat rather than video meetings. And I have sat in on the text chat meetings occasionally. They use Matrix. Yeah, there's not really. The working groups get to choose what collaboration tools they use. So it varies from group to group.
Every once in a while, I get on YouTube a notification about some rest group that like did a Zoom meeting and recorded it or something.
Yeah, I think like the compiler group and some of the other main groups published their meetings on YouTube, just so people can see what's going on and how the.
Did we lose them all when AJ left?
Maybe. I didn't see anybody in Jitsi.
We did a sound check at one point because we didn't hear anything, but they were there just
Yeah.
multitasking in the background.
Sounds like the voice artist that did all the voices for Asterisk.
So everybody's gone.
No, people are here. For some reason, I get a different participant set now that I do the.
Oh.
So, not sure what the deal is there.
Let's throw the mic over to them to see if they have anything they want to talk about.
All right, y'all. Another chance to speak up. Oh, I obviously can't do that. There we go.
That's cool.
So I've got like a $1,500 conference room process.
Somebody was just talking. Is your volume up? Are you on mute?
We were using.
I was
You're muted on Discord.
Right.
But we were using Jitsi. You did give it permission to use your mic before.
I did. Where's Jitsi? It's none of those, is it? It's not in Safari.
Firefox.
No. Chrome. Where's Chrome? It's not on here. Huh.
It's all communication programs.
Am I even on there? Can you see my screen?
I can see your screen. It is sharing this screen though.
Yeah, share that screen up there. Well, what's sharing it?
Once we deduce the mystery.
So easy, Max. So easy. You should don't know what you're doing. So can the people online? Can we hear them? Can they speak? Let's call them out one by one, and that's what they're working on.
I don't see a Jitsi tab anywhere here.
Well, I was looking at these Devolo products. Have you guys ever used this? It's a Ethernet network adapter with a Wi-Fi mesh built in. I'm curious because I just bought a house up in Provo, and I need to run some network cable all over. But if these work as good as they say, I don't need to run network cable. I can just plug a few of these in.
You can't beat actual Ethernet cable for networking,
Oh, right.
but sometimes power line stuff.
These guys claim a 2 gigabit per second transfer rate over the power line adapter. And that would be sufficient for me for most things.
Yeah, this is something.
It depends on how the wiring in your house is done.
That's true. And that house is really old, so.